Muito obrigado e boa tarde. Infelizmente vou continuar em inglês, mas pronto. So my title here on the slide is a little bit shorter than in the presentation, but I was asked to give a presentation on what is happening with the smart buildings issue and what's happening with energy efficiency, and are they really competition for one another, or are they actually enforcing? And from BPIE, we are quite convinced it's the latter. So actually, energy efficiency and the smartness of a building is enforcing each other. And my presentation is about that. I also will end my presentation a little bit about what's happening on European level. You're quite far away from what's happening in Brussels. You just mentioned NZEP. Can I maybe ask to the audience, who of you is familiar with terminology of NZEP? Who knows NZEP? Okay, so not that much. So there is, well, actually next week, I see some people waving. So actually, next week, the European Commission will launch its winter package. And in that winter package, there's a lot of new proposals for European legislation. There are some leaked versions that came out already that explain what might be in there, and I will end my presentation with that as well. And just to continue, so a very small word on BPIE, or Building Performance Institute Europe. We're based in Brussels, and we are a not-for-profit think tank, and we really focus on this energy performance of buildings, because we noticed when we started in 2010 that there was not such an organization on European level supporting the European players. So we work quite often for the European Commission, for the European Parliament, but at the same time we are based as well in Berlin and in Romania and in Poland, and we work on country level as well. For example, I was last week in Serbia, because Serbia wants to enter the European Union, but then they have to implement this building performance regulation. So we went there to explain what happened in other countries. So we grasp the best practices for what's happening in which countries, and we try to communicate it to other countries. So just a very small history on what happened with energy performance requirements. Is that in 2002 there was a first energy performance of building directive. So this is a regulation on European level, and in that directive for the first time there was the obligation for each country to set out building standards. But there was just a mentioning that member states have to set out these building standards, but there was no ambition level, so every country could do what they want. You could say 500 kilowatt hours a square meter or 20, didn't matter. So that in 2010 there was a recast. So a recast means that there is a revision of that legislation. And so that moment, for the first time, there was an ambition level mentioned. And this ambition level was that energy performance requirements should be cost optimal. That means that you have to do a calculation over the total lifetime of a building. How much does the energy consumption cost? How much does it cost to have this investment in advance? So imagine, what is the cost of having 10 centimeters of insulation, but what does it gain on energy savings over 30 years or longer? So based on that, you have to put in your ambition level. And what is very important as well is that in that directive, for the first time was mentioned the concept of NZEP, nearly zero energy buildings. So I will not go in detail on that because my presentation today is not about that, but for example, unfortunately, Portugal, but as well countries like Germany, they don't have yet an NZEP definition, which from my perspective is well, horrible, because how can your building sector direct itself to the future if it doesn't know which energy performance you need to build? So when I used to work for the Belgian Flemish government, and in 2013 we set out this NZEP definition. So we said to construction sector, you have a lot of front runners, and I think a lot of people from you here are very much advanced, but you have lots of laggards as well. And I compare the construction sector with a big container boat, so they need a lot of time to turn. So actually you have to be able to tell what will happen in 10, 20 years so they can prepare themselves. So the fact that Portugal and Germany don't have their NZEP definition for public buildings yet, which have to be constructed in 2019, that's almost tomorrow. For a public building, how much time do you need to set this up? So what is happening right now is that there is the ongoing discussion on how to review this. And I will go later in more in detail, but a thing that probably will be in the next directive is the integration of a smart readiness indicator. So how smart is your building? Is this an NZEP 2.0? We don't know, we will see. a huge miss or a huge lack, according to us, is the existing building stock. All this regulation is a lot about new buildings and large renovation, but we really need to tackle our current building stock. And João told me that this morning he presented numbers on Portugal and energy poverty. It's correct. So the fact that in Portugal, what is it, 40% or 30% of people are not able to heat their houses adequately. Sorry, that's not of these times anymore. So I will present like 4 drivers of change. So what is changing the market to this smart building and to renewables and this monitoring process? And first, there is this complete imbalance of the power market. Portugal is doing quite well on level of renewables. You have quite a lot of wind. You have your hydro in the mountains. Unfortunately, photovoltaics for buildings is not really well supported by governmental level. But all these renewables, they make that you have an imbalance in that sense that there's not always wind, there's not always sun, and you have more hydro in winter time than in summertime. So that makes that energy is not always available when you need it. And I'm checking for the laser. Yeah. So this here is energy price an hour. So now you speak Flemish. It's Flemish. But an average, it has on the wholesale market an average price between 40 and 80. And last week it reached 700. So factor 12 almost. So imagine that at this moment you can decharge your battery or decharge your car that you're not using and sell it to the market for 4 or 5 times the price that normally you buy energy. So this is what is starting to happen already on industrial level. So large industrial players, they're doing demand response, but commercial and residential consumers are not doing so. So we really need to be able to have this peak shaving or shifting to be able to respond to this involution of the power market. Second driver of change, what is changing a lot, is that there is a power load growth. So that means that we are using more and more electricity instead of conventional. So we are using less gas, less oil, or we should do so to have a decarbonized energy system. And if you look to the European numbers on heat pumps, you see there is a steadily increase. And with the efficiency of buildings, your electrical heating will even go more up. And your transport, you will, as mentioned before, you will go in more and more electric vehicles. So all this, it's a good sign for decarbonizing society, but at the same time, you have more electricity demand and more peak demand, which you have to solve. So the third driver of change is that at the same time, we see that renewable energy and storage systems are really becoming more cheap. You can start buying them. And at lunch, I asked about photovoltaic and costs, and was a little bit surprised that you only can install 1.5 kilowatt, I think, before having to negotiate and so on. But in Germany and in Belgium, photovoltaic systems almost reached grid parity. Grid parity means that the cost of your photovoltaics is as much as the electricity. And here you see on the graph in green that around 2011 in Germany, you achieved grid parity because in black you have the price of electricity. So photovoltaics became from 2012 more cheap than actually buying electricity from the grid. You see in yellow, you see the curve for batteries. So right now it is still too expensive, but you see that it's the point of having grid parity for batteries is getting there. And so Germany is of course a front runner, but other countries are following. So and everybody, I think you might know this person from Tesla, Elon Musk. He's not the first inventing batteries and electric vehicles. I mean, there's lots of German companies, lots of European companies doing so the same. But what he is doing is he's putting a huge marketing campaign on that, and he's selling his product very well. And he's really making this achievable for end users. So I'm challenging you. If you want to buy a Tesla right now, you go to your mobile phone, you go to the website of Tesla, and almost tomorrow there will be a Tesla at your door. So they really have this very good business-to-consumer approach. So, and the last driver of change, I think, was mentioned before, Internet of Things. How do you call it? Internet das Coisas or something like that? Fantastic. So you have this Internet of Things that we had home automation starting like a decade ago, connected with internet, but now it becomes having this ambient intelligence. And I have a smart thermostat at home. I can check which temperature it is at home. I can adapt it. My thermostat lets me know when I'm traveling and I should have put it off. And probably now I can check that my wife put it on 25 degrees instead of 22 or something. So all these systems are popping up, and it's really increasing a lot. And it goes from alarm systems and energy measure and monitoring system to more crazy or stupid things like systems telling you that your plants are thirsty and need water. So it really is evolving in the direction. So if you go and see how buildings are interacting with its environment, first of all, they interact all the technical systems in the building as such, but you also interact on community level, on district level, and on a wider system. You can imagine, for example, having, I don't know, a brand of like Zara that has connected all their shops in Europe or even worldwide to their energy management system. They can perfectly do so. They can perfectly benchmark. At the same time, your buildings operate and are integrated in your energy system and, of course, with the transport. And what we want to say with that is that if you combine your buildings, your transport, and your power sector, you actually have the 3 largest consumers from energy. And your buildings play a crucial role in being able to balance these 3. So the buildings really have this role, and we call it a kind of a micro-energy hub. Sometimes it's also called prosumers, but we think that prosumer, the word does not cover what it stands for. So buildings have their own energy production, solar, thermal, photovoltaics, biomass. They are storing their energy, or they're already a long time on heat with your collecting systems, but also more and more demand responsive. But one thing we cannot forget is how to connect this with the energy efficiency story. And so my next slides tell about why actually your energy efficiency is a precondition for the smartness of a building. So this is a very rough structure, drawing illustration of how a peak period might look like for a building. So you have your consumption at a certain moment which goes higher, and then you have that's your baseline. So you could say with demand response, you have a shedding. That means that you just stop consuming energy at a certain moment, or you can shift it. So you can have at a certain, for example, your dishwasher, you don't put it at this time, you just put it later or sooner. Or you charge your car not at this moment, but you charge it later or before. You can also have on-site renewable production, and on industrial level this happens a lot. So you have CHP, cogeneration. So industry uses a lot this system. If energy prices on industrial market go up, then there is they produce their own CHP, electricity and heat. But then what is a function of energy efficiency? And that makes it interesting, because if you have an overall energy efficiency, you actually lower in any way your peak demand. So that is something we cannot forget. And if this would be your baseline instead of the black line, you're already much more further. So that's the first reason why to focus on your energy efficiency. Second is a relation between energy efficiency, demand response, and increasing interaction with the grid. And so you have your energy efficiency, and then you could say, okay, we have time of use energy billing, so in the weekend it's more cheap, or in the evening it's more cheap. Or you can even say daily peak load, so between 4 and 6 we don't put on air conditioning because prices are higher. You can have a prediction of the day in advance that tomorrow there will be lots of sun, so there will be lots of photovoltaic production, so we will use more. Or you really have a real-time demand response. So that means that right now there is a lack of energy on the wholesale market, so my building adapts to that. So the further you go to the right, the more you have an increased interaction with the electricity market, and the more you need control systems and a better measurement. So a last thing on this energy efficiency is we absolutely need to decarbonize the heating. And for Portugal, that's a little bit less, because your heating demand here is much less compared to East Europe or to North and West Europe. But in general, you can say that across Europe, heat pumps and district heating is the best solution on level of decarbonization and of level of costs and fuel consumption. So I spoke before about demand response and shifting your energy. With some lighting and some LEDs, you won't have your mass load, so you really have to focus on this thermal appliances. So heat pumps in energy efficiency in energy efficient buildings achieve a much better seasonal performance factor. So honestly, I don't believe of adding heat pumps to buildings which are not efficient, because then you're just heating electrical instead of using the renewables from it. So at the same time, if everybody shifts from gas or oil to heat pumps, you will create even a higher peak demand, and that's what we actually don't want. But then here it becomes interesting, because if you can use demand response on heat pumps, you really can cause a reduction in your peak electricity demand. And this is a modeling study being done by the University of Leuven in Belgium. And in blue, you see the performance, the building performance with heat pumps without automatic demand response, and in red with automatic demand response. And you see that on the horizontal x, you see the nominal electric power, so the amount of power of your heat pump. And the lower range of power, you can reduce their peak demand to 0. And the higher, less. So that actually shows that peak shaving is really efficient or effective at low capacity heat pumps. And that actually makes us conclude that demand response is really most optimal for energy efficient buildings. So that's a little bit the story on how to combine demand response and energy efficiency. We spoke before about monitoring, and in Dutch we have this expression, and we say measuring is knowing. You only will know if you measure. And this was an interesting project in Belgium as well, by the University of Ghent. I'm not the one of Leuven. And you see on the horizontal x the normalized design heat use. So the building, it was actually a group of social buildings in the same district. So very similar buildings on level of size, on level of construction method. Some were at the corner, some were better oriented. So therefore they have a little bit of different designed energy consumption. But on the vertical x, you see the actual heat use measured. And what is significant, in green you see those that consume less than what is designed. In orange you see those that consume more, but not more than a double. And in red you see those that consume more than the double of the designed heat. What was very remarkable is that 1/4 of, so 25% of the buildings, they consume half of the total heat use. And you see here there are really some 3-4 buildings which consume 4 times more than the designed heat consumption. So at this moment you can go and look these 3-4 buildings and say, hey, what is happening here? And in this case I don't know what happened, but I know a case from a different story from a social housing company. And there they pinpointed out one building, and they went there, and it was an older couple, 65, 70, and they received for their 50th anniversary, marriage anniversary, a dishwasher. But every day at 4 o'clock, they had this habit for drinking a coffee and getting their cooking. So they put their cups in the dishwasher, closed the dishwasher, and put it on every day. And they put the dishwasher on 4 times a day. Because in the past, they washed their dishes 4 times a day. So just taking this benchmarking, it can take out this kind of energy consumption. So we need absolutely to manage and monitor real-time energy consumption to continue these smart things. And I won't go in detail on that, but if you can go further, first it starts with your real-time analysis, but at the same time you can start seeing trends. And if you start seeing trends, you can also get warnings when things go wrong. You can get alarms like, hey, you're wasting 20 or 30% more than is expected. For example, my thermostat, he knows the outside temperature, and it adapts itself according. Well, it knows how much time it needs to warm up to a certain degree. So if I say at 7 o'clock in the morning I want it to have 20 degrees, he knows that if it's outside 5 degrees, he starts to heat up at 6 o'clock in the morning. So your system can adapt to all this. So that's a little bit on level of smart buildings and energy efficiency. Now something on the winter package that is coming on European level. So it is really a gigantic load of energy related legislation or proposals that will come. So there will be energy efficiency directive proposal, energy performance of building directive, an initiative on smart financing, renewable energy directive, and some bunch of other directives as well. So this will become really this big winter animal knocking at your door. Maybe less at yours, but a lot to mine. So we will have a happy Christmas of analyzing all of that. So from next year, the political discussion will go a lot about that. But just a few things I will highlight what is in there. In the former directive, there was written that there should be inspections obliged for technical systems. But now actually they notice that it's very burdensome, and at the same time for government very difficult to control that. While at the same time you could have this completely automated. So they say we set out new requirements for controls and building automation. So you can monitor and adjust your energy usage. That might be in it. So an example, what was in the leaked versions, I cannot say that it will stay in there. That's why I mentioned here it's a draft. But they say that buildings, non-residential buildings with more than 250 megawatt hours a year, so large offices, schools, universities, hospitals, these kind of buildings, they should have a continuous monitoring and analyze the energy system. At the same time, they should benchmark the building's energy efficiency, so compare with other buildings, detect if there is possibilities to save energy, and communicate with the technical so have a proper communication with the technical building installations. For residential buildings, larger than 100 kilowatt in West Europe, larger than 100 kilowatt, it's an apartment building of 10 flats. So they should also have this continuous electronic monitoring from 2023, where they warn the energy manager or the building owner that there is things happening. But more fundamentally, new measures, what is coming up or might be coming up. One is the smartness indicator. So it's really to inform the building owner how smart, what is the level of smartness of the building. I will go in detail on that in my next slide. But also one thing that might be interesting for those selling, charging points for electric vehicles, is that the Commission is saying like, okay, we really want to have this importance for electric vehicles. So what is the problem is that there's not enough charging points. So why not, if you build a new building or renovate, that's an opportunity to install an electric plug. And at the same time, if you have large multi-apartment blocks or non-residential like shopping centers, why not oblige them to have for every 10 parking places an electrical charging spot? So it might come up. This last one, it's quite controversial. There's quite some parties that are against it, like the big building owners, they're not in favor, so you have to lobby a little bit in Europe to keep it in. But this might change a lot. And last week I was in Barcelona on a fair on smart utility week on smart buildings and so on, and I met there a company, and they created a platform that as a user of an electric car, you can see wherever you are, there's charging points that you can connect yourself. And if at your home you have a charging point, you can put yourself on this digital platform and actually sell your electricity to somebody in need to do so. So it creates a lot of business opportunities as well. So on this smart readiness indicator, so first of all, Europe says like, okay, if we do an EPC, an energy performance certificate, why can't you indicate how smart a building is? And the aspects of that is, first of all, how much does your building adapt in response to the needs of the occupant? The example I gave from my smart thermostat, for example. But as well, empower building occupants by taking direct control of their energy consumption. So smart meters, but smart meters that you as an owner, that you can read, that you can use this data and so on. And then the third one is really, that's what I mentioned before, facilitate maintenance. So really a control system or a building automation system that tells you that you need a maintenance or that there is something strange going on. And the last one is adapt in response to the needs or the situation of the grid. So if the prices are high, that your building can adapt to that. And then just to end, two practical examples is the first time I give this, but I found it a very interesting case. It's in Denmark. They're front runner in quite a lot of things, and I spoke a lot about electricity, but I wanted to point this out because it's not only about electricity but also about heating. In Denmark, they are really the king of district heating, but this supermarket, this brand of supermarket, they really go for very efficient buildings, but at the same time they notice that actually their refrigeration system creates a lot of heat that they don't need. So this waste heat, they add it on the district heating. So not only you have a district heating with one center organization putting heat, but now as a client, you can also add your waste heat on it and sell it. And this particular supermarket in Sonderburg, they provide heat for more or less 16 residential buildings. So just to give you an idea. Second example is the Edge office in Amsterdam. So it is a very efficient building. There is no way about it. So they consume 70% less electricity than comparable office buildings. But at the same time, it has a very smart interaction with the users. If you drive there with your electrical car or by bike in Amsterdam, everybody drives by bike, of course, then the building tells you on your app, on your smartphone, where you can park, tells you which office that you can go and sit, tells you which meetings you have in which meeting rooms, and it goes that far that actually from the next software update, it knows how much sugar you want in your coffee. So these buildings, they start to exist. It is no rocket science anymore. So I think that's maybe the main message, is that all these technologies, they exist, and passive house buildings, all the technologies are there. They are adult, but now it's the challenge of spreading this out and lifting up the quality. So then to end, all our reports and publications are free available on our website, so please go and have a look. And in June, we had this report on smart buildings in a decarbonized energy system, pointing out 10 different principles on what smart buildings should do. And from the first week of January, we launched a report where we compare how smart ready the built environment is in each country. And how Portugal is doing, that will be for them. Okay, thank you very much. Thank you.